Good morning, everyone, and welcome to our next topic. So, welcome on our week 7 topic on soil resources. Now, before going into details about soil resources, soils are actually considered as fundamental to life on Earth. However, human pressures on soil resources are reaching critical limits nowadays. That's why careful soil management is one essential element of course, sustainable agriculture and also provides a valuable lever for climate regulation and a pathway for safeguarding services and biodiversity. Now, soil consists of matter in three states. So recalling, we have solid, liquid, and gas. And the solid component consists of a mixture of mineral grains plus material of biologic origin, or of course coming from organisms. When we say biologic organism, so soil is a product of weathering, so weathering processes, and a medium capable of supporting plant growth. But before that, when we say weathering is what? Weathering is, or of course, it's actually the breaking down of rocks, soils, and minerals, as well as wood and artificial materials through contact with the Earth's atmosphere, water, and jet. And of course, soil is a medium capable of supporting plant growth. Now, in terms of the liquid composition, so the water in the soil wets the mineral grains. So the soil moisture tends to contain high levels of dissolved substances. So both the nutrients and the moisture in the soil allow plants to grow. That's for the liquid component. Now we have also gas or gaseous component. Of course, in the soil we have carbon dioxide, methane, and oxygen fill the open spaces in the soil. So that's why if the soil is porous, meaning the pores, the open spaces are actually filled with carbon dioxide, methane, and oxygen. Now, to define or to provide definition of soil is unconsolidated organic and mineral material on the Earth's surface that is capable of supporting plants. So it is a dynamic natural body in which plants grow, that is composed of mineral and organic materials and even living organisms. So that's why, as I mentioned in the previous slide, that soil actually coming from or having biologic origin. So coming from the living organisms. So they compose living organisms. And in terms of the soil formation, so we have different factors for soil forming factors. First, we have the parent material. So when you say parent material, it's actually the rock that is slowly broken down by biological, chemical, and physical weathering. Or physical weathering processes in nature. As I mentioned, of course, weathering is considered as one factor that is responsible for the formation of soil. Now, in terms of chemical weathering, of course, chemical weathering causes an alteration to the chemical composition of rock due to a reaction. So water, for example, that is slightly acidic can dissolve rock. So that is an example of chemical weathering. Now we have also what we call the biological weathering. So when we say biological weathering, this is the effect of living things. For example, as the roots of a tree extend into the ground, so they can break rocks apart. So that's an example of biological weathering. And then we have also what we call, if you're familiar, we have the freeze-thaw type, where most rocks are very hard. However, a very small amount of water can cause them to break. So when water seeps into cracks and freezes, it then expands. So when there will be the increasing of the size of the cracks, the tendency, or eventually, the pieces of rocks breaking off, creating sediment, so forming what we call the soil. So that's for the parent material. Now, aside from parent material, we have also other factors. We have the climate. Now, so when temperatures are below freezing, decomposition of organic matter and water movement are slow. So in that case, the soil development in the humid tropics is accelerated by the rapid weathering of rock and soil minerals, and even the leaching of nutrients and the decomposition of organic detritus. So we have, when we say detritus, these are actually done or the product of detritivores. So what are those detritivores? These are organisms that somehow degrade decomposed material. So we have ants. So ants as considered as detritivores. Now, when we say leaching, so the process of leaching, this is the process of a solute becoming detached or extracted from its carrier substance. So that's actually leaching. Now, aside from the two factors, we have also topography. So, of course, the presence or absence of mountains and valleys, steep slopes which have little or no soil on them, because soil and rock are continually transported down the slopes by gravity. So moderate slopes and valleys may encourage the formation of deep soils. So organisms or biological factors, including plant roots, lichens producing acids, animals that burrow or tunnel, such as earthworms, voles, mix the soil, distributing organic and mineral matter. In terms of composition, so soil composed of 45% mineral particles, so broken down pieces of rock, 5% organic matter from humus, from dead organisms, worm castings, and even leaf litter. Then we have also 25%, so we have from water, from precipitation. And then we have 25% from air, more with sandy soil, less with clay soil. So why more, or 25%? Or yes, more on sandy soil than clay soil? Because of course, as I mentioned a while ago, sandy soil is porous, meaning with open spaces compared to clay soil. So the tendency, more air is present in sandy soil than in clay soil. Now, we have also soil organisms. Primarily, millions of organisms are present in the soil. So, millions in one just teaspoon of fertile agricultural soil. So what are those organisms present? We have bacteria, fungi, algae, we have microscopic worms. So we have example of microscopic worms, I'm not sure if you're familiar, so we have nematodes. Now, soil organisms provide ecological services such as worm castings. So soil organisms will fertilize the soil because the process of decomposition of living matter or organic matter to humus, and then the breaking down of toxic materials. We have also cleansing of water, and then we have nutrient cycling from decomposers or upon death. So of course these are the importance of soil organisms to soil itself. Then we have also organic. So organic coming from animal manure, bone meal, compost. So it could be slow acting or long lasting. So we have the soil nutrients, the nitrogen, we have the phosphorus, and we have the potassium. So the delay in availability to plants needs time for the organic material to decompose. So the delay causes the low level of nutrient leaching. And of course, it improves water holding capacity. So yun yung mga importance in soil nutrients. So primarily we have organic sources, so from animal manure and other animal sources. Then we have also inorganic. So inorganic, manufactured from chemical compounds. It's fast acting but short lasting. So compared to organic, slow acting but long lasting. Now, the purpose or the contribution of inorganic substances to soil, it's highly soluble, so immediately available to plants. So high solubility also makes it leach quickly. So the tendency, if there will be leaching, fast leaching, it will also contaminate the water or it pollutes the water. Inorganic substances will also suppress growth of microorganisms. So there are inorganic substances that could inhibit the growth of other microorganisms, even those helpful microorganisms. And we have also inorganic as the source of nitrogen gases that increase air pollution. And the production of inorganic requires much energy from fossil fuels, increasing carbon dioxide emissions. So inorganic substances somehow with environmental impact compared, or with higher environmental impact compared to organic. And in soil, there are different layers of, or in soil, we call it as soil horizons. So we have the O horizon, we have the A horizon, the E horizon, the B horizon, and the C horizon. So the O horizon is actually on the topmost, so loose and partly decayed organic matter. So the tendency, yung nasa taas, yung O horizon, yun yung pinaka-fertile among the soil. Kasi nandoon yung mga decomposed, decayed matter. Then we have the A horizon, so mineral matter mixed with some humus because it's in between, or it's actually next to the O horizon. And then we have the E horizon, primarily light colored. This is the zone of leaching. And we have also the B horizon, so the accumulation of clay from above going down. And then we have the C horizon, so partially altered parent material of the soil. And we have also the unweathered parent material. So if you try to dig the soil, then you will, or you can identify, you can determine the soil horizons. Now, so just to provide more details of the soil horizons. The O horizon, as I mentioned a while ago, is the topmost layer, or also known as organic or lither layer. Sabi ko kanina, ito yung pinaka-fertile among the soil layers. Kasi nandito yung mga decayed matter, nandito yung mga decomposed matter. And then, we have also the A horizon, or considered to be as the topsoil. And mostly, inorganic mineral with some organic material and even humus mixed in. And this is also a crucial layer for plant growth. And then we have the horizon, so alluviation horizon, where there is what we call the losing of minerals by leaching. And then we have the B horizon or the subsoil, so the zone of accumulation or deposition of leached minerals and organic acid from above, clay and minerals, so like iron, aluminum, and calcium. And then we have the C horizon, slightly altered parent material of the soil. And then we have also the R horizon, or we call it as the bedrock. So the bedrock is somehow, among the layers, the bedrock is less fertile. Yeah. So these are actually how the process of how soil organisms would actually help in the fertilization of the soil. So the process of the food web. Now, soil organisms, including ants, live in the soil in innermost numbers. So they are responsible for constructing tunnels and chambers that aerate the soil. Now, aside from producing decomposed matter, ants or some of the decomposers are actually helpful in terms of constructing channels or chambers for the air to pass through. So food brought in by ants and the leftover is eventually decomposed and add to the organic matter in the soil. So ants also bury seeds in the soil and help in reproduction, or of course help in the pollination process. Then we have symbiotic association between the roots of plants and fungi. So like for example, when the mycorrhizal fungi are absent from the soil, the re-establishment of certain tree species is retarded because the mycorrhizal fungi somehow provide for trees or plants to grow. So they will provide an environment for other plants to survive. Then, of course, nutrient cycling is very common or observable in soil because leaching causes some nutrient minerals to be lost from the soil ecosystem to groundwater. So the weathering of the parent material replaces much or all of them. Also, dust carried in the atmosphere help replace nutrient minerals in certain soils. Now, just an example about the Hawaiian rainforest soils. So the Hawaiian rainforest soils receive dust inputs from Central Asia, so which is a distance more than 600 kilometers away. But still, they are responsible for providing dust into the Hawaiian rainforest. So this is the process of the nutrient cycling in the forest, of course, still following the food web concept. Now, there are four main characteristics of soil. In order for us to understand the behavior, in order for us to understand the structure of the soil. So first, we have the soil depth. So this is the thickness of a soil from the surface to a root limiting layer such as the bedrock or the seasonal water table. Then we have also the soil texture. So this is the relative amount of sand, silt, and clay in a given soil. It affects more specific characteristics like porosity, drainage, and permeability of the soil. Then we have also soil structure. The shape and the size of soil aggregates influences the size distribution of pores in the soil. Now, the larger the pores, the greater the amount of air present in the soil. The smaller the pores, the lesser the amount of gases or air in the soil. And then we have also the organic matter. So the amount of organic matter within a soil, it affects more specific characteristics and is affected by soil management. So in terms of soil characterization, as I've mentioned, they are characterized by color and several other traits such as texture, structure, and pH. And even also, we have the presence of the organic matter and soil depth. So ito yung makikita nyo if you are to determine the characteristics of soil. The three main factors in determining the characterization, we have the texture, the structure, and the pH. Now, in determining the size particles, there are three main categories for soil texture. For clay, the particles are actually lesser than 0.02 millimeter in diameter. For silt, the particles is approximately 0.002 to 0.05 millimeter in diameter. And for sand, the particles is 0.05 to 2.0 millimeter in diameter. So best for plant growth is loam with an even mix of these three types. So we have the gravel, the sand, the silt, and the clay. So mas better yung loamy soil in terms for the agricultural production. Now, why? Because loam is an ideal agricultural soil. It has an optimum combination of different soil particles or particle sizes. It contains 4% of sand and silt and about 20% of clay. So generally, larger particles provide structural support, aeration, and permeability to the soil. So whereas smaller particles bind into aggregates or clumps and hold nutrients and water. So that's why if we compare loam to clay, in terms of the absorption process, loam with actually high absorption process compared to clay. Is a tendency clay soil having less pores. So the tendency, the absorption going down will be slower compared to loam or even to sandy with porous structure, meaning may mga air spaces. So dun yun dumadaan yung water. So kaya it cannot hold much water and it is really good for trees and we have plants. Now sandy soil is not desirable because they do not hold mineral or water, and plants grown in soils which are more susceptible to mineral deficiencies and drought. Now, sabi ko kanina na sandy soil is porous, but however, it's not desirable if you want to pursue for agricultural process or agricultural production. The tendency, they cannot hold much of the mineral, even water. So, hindi siya applicable for planting. Now, we have for clayey soil or for clayish soil, it provides poor drainage and often do not contain enough oxygen kasi nga walang spaces or pores or filled spaces. More on aggregates siya. And then, usually ginagamit in determining the texture, we have the texture chart. So it is possible to find the type of soil by making use of the soil texture chart. So we can determine the percentage of each component in a soil sample and then plot the results. So making sure the sum of the sand plus silt plus clay will always be 100%. So this is the chart that I'm actually referring to. So you can have the percentage, you can combine the percentage of the silt, the clay, and even the sand. So within 40 to 60%, may mga areas pa na considered as silt. This one. And then yung 0 to 40%, yun yung mga clayish na mga portion. And then we have also 40 to 50, may mga sandy na portion. And then we have 20 to 35, or approximately 20 to 40. Yun yung mga sandy clay loam soil. So, in understanding what soil is and how it forms, of course, we have the soil characteristics, or we have the different types of soil. So, one, we have the clay. So, the clay, the layer silicates that are formed as products of chemical weathering of other silicate minerals at the Earth's surface. So, they are found most often in shales, and the most common type of sedimentary rock, yung shales. And then we have also the silt. So the rock worn into tiny pieces, coarser than clay but finer than salt, or finer than sand. So usually 1/20 millimeter or less in diameter yung silt. And then we have the sand. Of course, quartz or silica worn down over time, so producing grains. So grains with diameter between 0.06 millimeter to 2 millimeters. And we have also organic matter, or we call it as humus. And then we have also the loam, or the loamy soil. So the soil containing a mixture of clay, sand, silt, and humus. And the loam soil, as I always mention, good for growing most crops, meaning good for agricultural production. Now, the soil pH naman ranges from 4 to 8. So, lesser than 4, that's the very acidic. Though 1 or 0 to 7 considered to be acidic, and then 7 and above considered to be basic. So, however, the soil is in between 4 to 8. So, the soil of the pygmy forest in the Mendocino County in California is acidic. So, as an example, so with a pH of 2.8 to 3.9. Now, why is it that there are acidic soils? So why there are areas? Of course, based on the previous discussion or previous slides, there are factors affecting the components of the soil. Yung kanina nasabi ko. So soils in Death Valley, California have pH of 10.5. So if yung pygmy forest is acidic, yung Death Valley naman is 10.5, so it's actually basic. So at a low pH, the aluminum and manganese in soil water are more soluble, and the roots absorb them in toxic concentration. So if the aluminum and manganese is present in the soil, so of course it's actually toxic to plants and animals, so not good for planting. Then certain mineral salts essential for plant growth, such as calcium phosphate, become less soluble and less available to plant with a higher pH. So an acidic soil has a relatively reduced ability to bind positively charged ions to it. That's why over acidic, or meaning higher acidity and higher basicity, will really affect the growth of your plants in a certain soil. So that's why soil scientists would tend to research, would tend to identify the soil pH in order for them to identify what specific species of organisms or what specific species of plants can actually thrive in that specific area. And then we have also the soil porosity and permeability. So I've been mentioning this one. So to define, when you say porosity, it's actually the volume of water that fits between the soil particles. So it's the pores, the opening, the air spaces in between soils. And then we have also permeability. So it's the rate of flow of water through the soil. Of course, we have what we call the percent retention. So how much water is trapped by the soil. And porosity and permeability are directly related. So when one is high, the other is high as well. So percent water retention is inversely related to both. So for the different types of soil, if you are to classify or if you are to determine the porosity and permeability, the clay having lower porosity and lower permeability. So in terms of water retention, higher yung sa clay. For silt naman, still medyo lower yung porosity and even the permeability, but still medyo mataas pa rin yung retention. For sand, very high yung porosity niya, very high naman yung permeability niya. So ang tendency, mabilis na absorb ang tubig or mabilis na nag-infiltrate ang soil underground, so lower yung retention niya. And then we have organic matters or the humus, so with high porosity also, with high permeability, but lower yung water retention. That's why humus or the loam soil is also good for plant processes or for planting plants. Then we have different types of soil. We have different examples of soil. So we have the alphy soil. You can actually check the illustration if you wanted to know what are these, what are the picture, what is the characteristic or what are the characteristics of the alphy soil. So alphy soil is brown to gray, brown a horizon. So moderately weathered forest soils, so usually found in moist temperate forests biomes, and most organic material is found in living plants. So alphy soil adequate for agriculture if supplemented with fertilizer or organic material. So you can check in your backyard, in your garden, if you have that specific type of soil. Next, we have the molluscs. So the molluscs primarily found in temperate, semi-arid grasslands, and they are considered to be fertile soils. So they are dark brown to black a horizon and rich in humus. So soluble minerals remain in the upper layers because the precipitation is not great enough to leach them into lower layers. So usually ito yung mga areas na parang semi-arid, yung mga medyo mainit. And molluscs are actually good or best agricultural soil. So most of the world's grain crops are grown in molluscs. Then we have also the aridisols. So aridisols with thin light color and contain a lot of sand. So found in dry lands and deserts. So they are susceptible for salinization. So when we say salinization, what about this salinization? So salinization is the process or the increase of salt concentration in soil, and in most cases caused by dissolved salts in the water supply. And anong nag-cause ng parang water supply, rich in water supply? Of course, we have your flooding by the land, by seawater. And then we have also brackish groundwater through the soil. Mga ganun. So aridisols, crops can be grown on aridisols if water is supplied by irrigation. So still good siya if the area is irrigated. And then we have also the oxysols. So the oxysols, low in nutrient materials, exist in tropical and subtropical areas with ample precipitation. So with less na ulan. So little organic material accumulates on the forest floor or on the horizon because leaves and twigs are rapidly decomposed in oxysols. So a horizon is rich with humus, and most organic matter is found in living plants or oxysols na type ng soil. Now, there are natural phenomena that would really affect the soil formation and the soil structure itself. First, we have the water erosion or the soil erosion. Now, wind, water, ice, and other agents promote soil erosion. So rainfall loosens soil particles and then transported by moving water. What are the effects of soil erosion? It reduces the amount of soil in an area and limits the growth of plants. Why? For the reason that when there will be erosion, the tendency, the next portion, or when the top portion is eroded, the next portion will have less amount of nutrients. So it causes the soil to lose its fertility because essential nutrient, mineral, and organic matter in the soil are removed. So, yung sabi ko nga, na if there will be flooding, the tendency of the upper layer will become infertile, meaning not good for planting. So it leads to loss of productivity of crops and use of more fertilizers kasi nga hindi siya nagkaroon ng nagkaroon ng losing of fertility. So sediments that gets into water bodies affect water quality and fish habitats. So sediments with pesticides add to pollution not only at home but also in the environment. Now, the causes and prevention of soil erosion, it is considered also now as soil management. So, because of soil erosion, so most of the scientists nowadays, most of our researchers nowadays would tend to look for studies or look for idea how to prevent the soil erosion. So the cause of soil erosion, we have poor soil management practices, poor agricultural practices, removal of natural plant communities or the vegetation, unsound logging practices, clear cutting large forested areas, and the sufficient plant cover limits the amount of soil erosion. Roots help to hold the soil in place. That's why we need to plant trees in order for the soil, or in order for the plants, the roots to hold the soil. So primarily, yung sa mga steepy area, kailangan nyo ng mga puno to hold the soil sa mga puno. Now, there are also tendencies that there will be nutrient depletion sa soil. So as plant and animal detritus decomposes in natural ecosystems, nutrient minerals are cycled back to the soil for reuse. So in agriculture, much of the plant material is harvested because the nutrient minerals in the harvested portions are unavailable to soil. So the nutrient cycle is broken and the fertilizer must be added periodically to the soil. So kaya nga nagkakaroon tayo ng parang tinatawag na intercropping. So, hindi yung pare-pareho yung itinanim like ngayong planting season, ganito yung itanim mo, the next season is ganun pa rin. No. There should be differences in the crops or the plants that you need to actually put when you do like agriculture. Para hindi naman maubos yung minerals and nutrients in that specific area if paulit-ulit yung itinanim mo. Why? For the reason that similar species of organisms that you will be planting in soil will have similar resources needed. So kung magkaubusan, of course, it would affect the production. So kaya ganun. Now, we have what we call the salinization. So, sabi ko nga kanina, it's actually the formation or the increase of salt concentration. So, the gradual accumulation of salt in soil, often as a result of improper irrigation methods. So, irrigation water contains small amounts of dissolved salts. So, the continued application of such water leads to the gradual accumulation of salt in the soil. So, yung mga irrigated type, sa continuous usage of irrigation and tendency, nagkakaroon ng infiltration of too much salt sa mga farmlands nyo. So when the water evaporates, the salts are left behind. So particularly in the upper layers of the soil, which are the layers important for agriculture. Now, the level can get high to an extent that plants can get poisoned or their roots get hydrated. So when soil is waterlogged, capillary movement may carry salts from groundwater to the soil surface where they are deposited as a crust of salt. So we have the salinization in farms. So irrigation water contains small amounts of dissolved salts. Evaporation and transpiration leave salts behind. So salt builds up in soil. So in waterlogging naman, precipitation and irrigation water percolate downward and then the water table rises. So when we say percolate, the definition of percolate is actually, this is so it's actually percolating, meaning the trickle or cause to trickle through something porous. Or it's somehow to put through a sieve. So yun yung percolate. So how to prevent soil salinization? Of course, reduce irrigation. So switch to salt-tolerant crops such as barley, cotton, and sugar beet. So in terms of cleanup also, flushing soil, expensive and wastewater, not growing crops for 2 to 5 years, so there will be changes for your crops. Installing underground drainage system. However, this is somehow expensive. Then we have also the desertification. So what are the causes of desertification? We have overgrazing, deforestation, erosion, salinization, soil compaction, and natural climate change. And if those are the causes, there are also consequences. So worsening of drought, famine, economic losses, lower living standards, and then environmental refugees. So Asia and Africa, the largest land areas with extensive soil damage and rapid population growth is the main cause. So that's based on study. So prolonged periods of drought would really affect also the soil composition and even the plants and animals. And overexploitation leads to desertification. So the utilization of tools and techniques to build soil. First, we have the soil conservation, so including the terracing and the ponds, the contour farming, the shelter belts and the windbreaks, and then we have also the conservation tillage. So yun yung mga ginagawa in order for ma-conserve yung soil. Now we have also the organic and inorganic fertilizers. Now what's the difference? So organic fertilizers is all natural and includes things such as bat guano, compost, peat moss, wood ash, and manure. So these organic soil, or these factors would somehow amend the fertility of the soil. So they don't burn or harm plants, and they can have long-term positive effects on the soil without damaging the groundwater. While on the other hand, inorganic fertilizers are actually artificial or synthetic fertilizers. So when plants are in dire need of nutrients because they are already dying, an inorganic fertilizer is the most immediate solution to infuse nutrients immediately to the plants. Then we have what we call the soil reclamation. So soil reclamation, this is stabilizing the land to prevent further erosion. So restoring the soil to its former fertility to stabilize the land. So the bare ground is seeded with plants that eventually grow to cover the soil, meaning to hold the roots, or to hold the soil by the roots. Then plant shelter belts to lessen the impact of wind. And then restoration of soil fertility to its original level is a slow process. So the use of land must be restricted it cannot be farmed or grazed if we wanted to restore the soil fertility. So aside from synthetic materials, some would also use, or some are actually using organic material for the soil. So I guess that would be all. Thank you for listening. I hope you learned something from the discussion, and I do hope that we can actually, or we can have another session of the topic, or another topic to discuss. So if you have questions, you can direct your question to me through our GC or through our Facebook page. So if you want to ask questions, if you have concerns, direct it to me, because people cannot help you. It's my subject, so I'm the one who can actually help you. So thank you very much for listening, and have a good day.